Hi, welcome to Unit 5 on sampling distributions. This is topic 5.2, the normal distribution revisited. A lot of what we're going to talk about in this video, we actually covered way back a couple units ago, but we are going to revisit it again because it's a really important topic. At this point, you might be like, how is the normal distribution connected to sampling? Well, trust me, you're going to find out. And when we want to talk in the future, in the next couple lessons, about how samples vary, what we're going to find out is that when we think about how samples vary, they typically follow the normal model, which is why we really need to remember how to understand and utilize the normal distribution. And that's what this video is all about. So let's remember what continuous random variables are. A continuous random variable is a variable that can take on any value in a specified domain. Every interval within that domain has a probability associated with it. So let's give an example so this makes sense. Let's let W be the continuous random variable for how much time it takes Josh to wash his car. Josh knows from past history that it will take him anywhere from 5 to 25 minutes to wash his car. So the domain for his variable is somewhere between 5 and 25. And I used an X there. I guess I should have used a W for, again, washing his car. But the point is that the min is 5, the max is 25, but any subset of that domain has a probability that is possible to find depending on the shape of the distribution. For example, I could find the probability that it takes between 10 and 15 minutes to wash a car, or between 6 and 8 minutes to wash a car, or between 12 and 20 minutes to wash a car, or less than 17 minutes to wash a car. The one thing I cannot find is the probability of an exact value. Sorry, you cannot do that with the continuous random variable. With a continuous random variable, you can only do intervals between two values or above or below a value. You cannot find the exact value. So if I said, hey, what's the probability that it takes him exactly 17 minutes to wash a car? Sorry, that is actually not possible with continuous random variables. So please keep that in mind. All right, so continuous random variables connecting with the normal distribution. It is very, very common for a continuous random variable to be described with a normal distribution. Recall, a normal distribution is bell-shaped or mound-shaped. It's unimodal and symmetric. So if you recall, I hope everybody remembers this. If you recall, the normal model is this nice, symmetric, mound-shaped, unimodal, bell-shaped distribution. Now remember, to understand the normal distribution, you must be given the mean and the standard deviation. Mu and sigma, what is true for the entire population must be known. Now, finding probabilities with the normal distribution is really unbelievably easy because the area under a normal curve over a given interval represents the probability that a particular value lies in that interval. And I know you might be like, oh, okay, you said it's easy. That doesn't sound very easy. Well, trust me, it is very easy, and you'll find that out in this video. So let's take a look at a normal model here. And remember, a standard normal model has a mean of 0, and then it goes up 1 standard deviation, up 2 standard deviations, and then up 3 standard deviations. Now, there is 4, 5, 6, 7, but it's very, very, very unlikely for a value to be more than 3 standard deviations above the mean. Likewise, we could go down 1 standard deviation, down 2 standard deviations, or down 3. Again, we could go down 4, 5, 6, but again, it's very unlikely to be below 3 standard deviations. So the standard normal model has a 0 for the mean in the middle, and then a 1, a 2, and a 3 to go above, and a -1, a -2, and a -3 to go below. So the idea here is that any interval inside of this normal model is represented by the probability of you being within that interval. You know, for example, if I wanted to go from -1.5, right here, -1.5, to +0.5, right? +0.5, right? Any value in that interval, right? The area in that interval between that -1.5 and that +0.5, that is the probability of being in that interval, right? So what is this -1.5? What is this +0.5? Those are z-scores, right? A z-score is how many standard deviations you are above or below the mean. So again, this shaded green area is anywhere from negative 1.5 standard deviations below the mean to 0.5 standard deviations above the mean. And that area could be looked at as the probability of being in that interval. All right, so now all we got to do is look at an example that connects the normal model to a specific problem, like, for example, Josh washing his car. All right, so assume the time it takes Josh to wash his car follows a normal distribution with a mean of 15 minutes and a standard deviation of 3.5. So that means his mean is 15 minutes and his standard deviation sigma is 3.5 minutes. Those are the only two numbers I need to answer any probability question connected to this scenario. So I actually want to do four things here. I want to draw a picture of the distribution. I want to find the probability it takes Josh over 10 minutes to wash the car. I want to find the probability it takes Josh under 8 or more than 20 minutes to wash the car. And I want to find the probability it takes Josh between 12 and 20 minutes to wash the car. Now I want to note for the second time in this video, I cannot find any exact value in of itself. So if I say, what's the probability it takes Josh exactly 16 minutes to wash his car? Cannot find that. The normal model is incapable of doing exact values. It can only do intervals, above, below, or in between. All right, so let's take a look at these four things with my picture. So here's my picture, right? Right smack dab in the middle is the mean, which again is represented by, generically represented by 0. So the mean of 15 minutes is 0 standard deviations from itself. That's why the mean generically gets turned into a 0, because the mean is that it should take Josh 15 minutes to wash a car. So that means his Z-score is 0, because the mean of 15 is 0 standard deviations from itself. Then what I did was I went up 1 standard deviation, so I went up 3.5. Then I went up 2 standard deviations, which is going up 7. Then I went up 3 standard deviations. So I went up 3.5, up 3.5, up another 3.5. Could I go higher? Yes, but it's very unlikely, so we just don't do it. We don't show it in the picture at least. Then I went down 1 standard deviation, 3.5 minutes. I went down 2 standard deviations, 7 minutes. And then I went down 3 standard deviations. So here is my representation, the normal distribution of how long it takes Josh to wash his car. Now what I want to do is I want to find these probabilities. Notice this is the proper notation, right? This is in context. So I'm finding the probability it takes Josh more than 10 minutes to wash his car. Then I'm going to find the probability it takes Josh less than 8 or more than 20. So I'm going to do that by adding. Remember, these are two separate things. So I got to find less than 8, and then I got to find greater than 20, and I got to add them together. There's no overlap there because you cannot be less than 8 and more than 20 at the same time. That's impossible. So I'm just going to add those together. And then this is actually an interval where I'm going to be looking in between. So I'm going to be looking in between 12 and 20. So let's kind of just talk about this first one, for example, more than 10. So 10 minutes falls somewhere right around here, right? Somewhere between 8 and 11.5 is 10 minutes. And I want to find the probability that I am more than that. So I want to find all of this area over here. Because remember, the area over here is equivalent to the probability. So how do I find that area? Well, that's where the calculator and normal model could really help us out. So basically, it's a pretty simple process. The first thing I have to do is find the corresponding Z-score. Then I'm going to use my calculator, and I'm simply going to ask my calculator to find the probability, to find the proportion, to find the area, it's all the same thing, that I am above that Z-score for this particular problem. So let's actually remind you of how the calculator could do that for you. So first off, we need normal CDF to calculate probabilities with the normal model. To get normal CDF, you hit second and then vars. So on my calculator, I'm going to hit the second button in the top left and then vars, which stands for variables. You'll see option 2 there is normal CDF. Now, the only thing you have to understand is that when you use normal CDF, oh, and by the way, if your calculator screen does not look like mine right now with lower, upper, mu, sigma, and pace, you need to go to mode and put yourself in Stat Wizards turned on. So under mode, we're Stat Wizards, make sure it's turned on. All right, so once again, second vars, number 2 here. All right, now, it's important to keep in mind that the calculator only speaks in the language of z-scores. So when it talks about a lower and an upper value, it's talking about z-scores. So I do need to remember how to calculate a z-score for a given value. It's a very simple formula. It's your value, x, minus the mean divided by the standard deviation. And remember, a z-score by definition is how many standard deviations you are from the mean. Then you're going to think left to right. So the lower is the z-score to the far left of your interval, and the upper is the z-score to the far right of your interval. Now, if the lower or the upper is infinity, well, there is no infinity button on your calculator, so we're going to use 99 to represent positive infinity. That would be an extremely high z-score. I mean, come on, we stop at 3. So a z-score of 99 would be like unfathomably high. And negative 99 would be infinity all the way to the left, okay? So once you type in these values, then what you're going to do is you're going to hit paste, and it pastes it into the home screen, and the pasting will look like this, right? So it's going to have it'll say normal CDF, and then it's going to have the lower z-score that you typed in, the upper z-score that you typed in, and then remember, since the calculator only speaks in the language of z-scores, it's going to need a 0 for the mean and a 1 for the standard deviation, because that's the generic, right? Any mean could be looked at as a z-score of 0 because the mean is 0 from itself, and then the standard deviation is represented by 1. You could be 1 standard deviation from yourself, 2, 3, and so forth in each direction. All right, so let's recap exactly what you have to show to get the answer. And it sounds like this is a long process, but when you actually do it, it's very quick. So a lot of kids ask me, what do I have to show? Well, you have to show the work to find the z-score. So the question is, what's the probability it takes Josh over 10 minutes to wash his car? So the first thing I have to show my work of, and I have to show my work very neatly, just like this, is how to find the z-score for 10 minutes. It's very simple. 10 minus 15 divided by 3.5. And please label that with a z. I hate kids that just show the work. They don't actually call it a z-score. You know, call it what it is, please. So get on your calculator. It's pretty easy. So I'm just going to do 10 minus 15. You have to hit enter first, right? Follow order of operations, do the top first. Then divide it by 3.5. And always round it to 4 decimals, just for accuracy. So I said negative 1.4286. Then the calculator is really going to do the rest of the work for you. What you have to do is label your answer properly. So first, I'm going to give the context. I'm finding the probability that it takes more than 10 minutes to wash a car. So W representing washing a car, and I'm looking for it to be more than, greater than 10. Now, this is equivalent to the z-score being more than negative 1.4286. Right? This is the z-score for 10 minutes in my particular problem. So these two statements are equivalent. One is in context to washing a car. One is the equivalent for a z-score. You have to show both of those if you want full credit. Then what you're going to do is use your calculator to get the answer. So remember, on my calculator, I'm going to go to normal CDF. Now I'm looking from the z-score of negative 1.4286 as my lower. So negative 1.4286. And my upper value is going to be 99. That's really, really high, right? That's way more than, right? It's technically infinity, but I don't have an infinity button. And then again, always leave the mean as 0 and the standard deviation as 1, because that's the generic normal distribution. And then again, when you paste that, it brings it to your home screen. And what I'm also going to ask you to do is write that on your paper. So you're going to write normal CDF. Negative 1.4286. And again, this is all on your calculator screen. So all I'm asking is that you rewrite it. And then again, do me this favor though. Don't put a 99. A 99 is what we're putting into the calculator because we don't have an infinity button. I want you to actually put infinity here. So this is representing that we're finding the probability, the proportion, the area from this z-score all the way towards infinity with a mean of 0 and a standard deviation of 1. So again, this is all going to be on your calculator screens. You just have to rewrite it. Then, once you hit enter, boom, there's your answer, 0.9234. Obviously, write that down. So, I know you're like, what? This is going to take a while. But it's really not, guys. It goes fast. So, the first thing you have to show is how to find your z-score. Show that work. Label it with a letter Z. Then you have to show context for what the question asks. convert it to a Z-score for what the question asks. Then when you type all that into your calculator, just recopy what the calculator pastes into your home screen, and that's again using the normal CDF. Don't use a 99, use an infinity symbol, because that's what that 99 is representing. So what we just found out is that there's a 92.34% chance that Josh takes over 10 minutes to wash your car. Well, the average is 15 minutes, so it's very likely it's going to take more than 10 minutes to wash a car. All right, now what I want to do is answer the remaining questions, but again, it should go a lot faster than that we know the process. So here are the two remaining questions. What's the probability that it takes less than 8 or more than 20 minutes? All right, what do I got to do? I got to show the work for my Z-score. So I'm going to quickly show the work here. Now I got to do 2 of them, sorry, because I got to do 8 and 20. So I'm showing my work. Try to be as neat as possible. Make it legible. So here we go. 8 minus 15. Do the top first. Divide it by 3.5. That's -2. And that works out nice when they're whole numbers, right? You don't have to worry about rounding. Then I'm going to do 20 minus 15. Divided by 3.5 as well. And that works out to be 1.4286. 1.4286. All right. So now what I'm going to do is I'm going to write down in context what I'm trying to find. And that's actually already written on my paper, but you would rewrite it. The probability that I'm going to take less than 8 or, which means I'm going to add more than 20. And that is equal to the probability that a Z-score is less than -2. And I'm going to add that to the probability that a Z-score is more than 1.4286. Again, so this is equivalent to saying less than 8. This part right here is equivalent to saying more than 20. And then now I'm going to go to my calculator. Second vars, number 2. And now I'm going to do the first one, right? So I'm going to look lower than -2. So I'm going to start with -99 because I'm going to start all the way to the left. If I'm looking lower than -2, that's way, way down at -infinity to -2. Be careful that you use the negative sign. Some kids hit the minus by accident. A minus sign is an operation, right? We need the negative symbol, which is right here below 3. So -2. So this is going to find me the probability that I am below 8. So again, let me write that down on my paper. So again, that's normal CDF going from -infinity to -2 with a 0 and a 1. And the answer to that was 0.0, I got to go back to my calculator, forget what it was, 0.0228. Okay, so there's about a 2.28% chance that we're lower than 8. Now we have to add to that greater than 20. So once again, I'm going to go to normal CDF on my calculator. This time I'm going to start because I'm going greater. So I'm going to start at 1.4286. And I'm going to go to 99. I'm going to go way above 20, which again, on my calculator, 20 minutes is equivalent to 1.4286 standard deviations above the mean. And I'm going to go ahead and paste that into the home screen as well and get my answer. But again, I got to write down that again, what am I doing there? That's a normal CDF. And again, that's going from 1.4286 to 90 or to infinity to 0, 1. Sorry, I got to kind of squeeze that in there. And again, the actual answer to that is 0.0766. So I'm going to add to that 0.0766. So again, here's the probability that I'm less than 8. Here's the probability that I'm more than 20. Now I just got to add those two values together. So 0.0228 plus 0.0766. Oh, I forgot the 0 there. 0.776. And I get 0.1004. So the probability that it takes Josh less than 8 or more than 20 is about 10.04%. So again, I explained all that. This is kind of a double problem because you're doing two things at once. You're doing less than 8 and more than 20. But this is a good problem. That way you see all the work that needs to go into it. So this is all the work you would need to show as neat as possible on your paper. All right, let's do this next one, looking between 12 and 20. So we're trying to find the probability that it takes Josh between 12 and 20 minutes to wash his car. All right, so the first thing I do is I got to find the Z-score, and I got to show my work for the Z-score for 12. And the z-score for 20. Now, the good news is I already know the answer to the z-score for 20 because I found it above, but I still got to show my work. It's a separate problem. But at least I don't have to actually go and do it because I already know the answer. But I do got to go to my calculator real quick and get 12 minus 15 divided by the standard deviation. That's a z-score of negative 0.8571. Negative 0.8571. All right, so now here is the context. I'm looking for the probability that we are between 12 and 20, which is equivalent to the probability that a z-score is between negative 0.8571 and positive 1.4286. Hopefully you guys will be a little bit neater on your paper. Again, it's tough for me to do the writing on this programming here, but you get the idea. All right, now remember, to get that answer, I'm going to go and grab normal CDF. And I'm looking in between two values. I'm looking in between negative 0.8571 to positive 1.4286. And again, when I paste this into the home screen, it's actually going to show me that. And I'm going to hit enter to get the answer, 0.7277. But I'm requiring that on your paper you show me normal CDF. And you're going to go from a low or lower point, negative 0.8571, to an upper value of 1.4286, using a mean and a generic standard deviation of 0 and 1. And of course, the answer we just got was 0.7277. So there's a 72.77% probability that it takes Josh between 12 and 20 minutes to wash his car. Okay, so now you know exactly what you have to show, and I hope you do remember this, and you remember how easy it can be, but I'm really asking that you show this work here to get these answers. All right, now what else can we do with the normal model and these continuous random variables? Well, we can also find intervals. Remember, the normal distribution shows the intervals and their probabilities. We can now answer questions like this, right? We could go both ways. I could give you an interval and you find the probability, or I could actually work backwards. So the question here is, what interval of times would mark the middle 30% of times it takes Josh to wash a car? So now I'm looking for the middle 30%, right? The 30% probability that's in the middle. So to answer this, I really have to think about the interval. I have to think about the ends of the interval. So if I think about the times it takes Josh to wash his car, right? Here's 0 all the way to 100, right? 100%, right? I'm talking about probability here. We're looking for the middle 30%. The middle 30%. Now, what I have to understand is just, think about this. The middle 30% leaves 70% on the outside. But because the middle 30% is the middle, then that outside 70% gets split up, 35% at the bottom, 35% at the top. So there's the middle 30% I'm trying to find, which puts 35% below it, 35% above it. Again, it all adds up to 100%, but I'm looking for that middle 30%. So I'm looking for this middle 30%. I'm trying to find out what values represent this middle 30%, right? And again, you have to understand that that puts 35% below my interval, and that puts 35% above my interval. All right, so how the heck do I get the answer, right? Now that I kind of comprehend what's going on here, how do I get these numbers? Because what I'm after are these numbers right here. What is this lower value, and what is this upper value that represents that middle 30%? All right. So to solve this problem, we need to really do three things. We have to first understand the probability in, below, and above our interval, which I just explained to you. Hopefully that makes sense. Then we have to find the z-scores that mark the ends of that interval. And then I need to use the z-score formula to solve for those times. So again, what I'm actually after here is I need to find the z-score that represents the beginning of this interval and the z-score that represents the end of this interval. Once I have those z-scores, I could then use the z-score formula to solve for the actual time at the bottom and the time at the top. So the big question is, how the heck do I get those z-scores? Well, remember, we have a cheat on our calculator. So your calculator can actually find z-scores for you if you give it the proper probability. So let's talk about how to do this. All right. First off, to find z-scores on your calculator, you need to hit second vars. So on my calculator, I'm going to once again go to second vars. And this time, I'm going to use the number 3 option, which is invert norm. Here's how invert norm works. You type in an area or a proportion, a probability. It's all the same thing, right? When you're talking about that normal model, an area in it between an interval is equal to the proportion in that interval or the probability of being in that interval. So the calculator just says area. But it's what I need you to really remember is that the area it's looking for is the area below. I wish it said that, but it doesn't. But you need to listen to me and know that the area it's asking for right there is the area below. So let's think about what I'm trying to find. Go back to what I already discussed. I'm looking for the middle 30%, which puts 35% below and 35% above. What I want is this z-score at the bottom of the 30% and this z-score at the top of the 30%. To do that, I have to understand how the calculator works. Remember, the calculator only wants the area below. So to find the first box, the bottom of the 30%, I'm going to type in 0.35 because there's 35% below that bottom value. And the z-score is negative 0.3853. So that z-score right there is negative 0.3853. All right, now I have to find the z-score at the top. All right, so what percent is below that? Well, remember, that's invert norm only wants the percent below. So below that would be the 30 and the 35. So it'd be a total of 65% below that box. So when I go back to invert norm here, I'm going to type in 0.65 this time, and I get positive 0.3853. Now, what I want you to understand is that's not a coincidence that I got a negative and a positive. Because of symmetry here, if I'm looking at the middle 30%, the bottom and the top of that interval should be the exact same z-scores, one negative, one positive. So you actually don't have to do it twice. If you find the bottom, negative 0.3853, you should automatically know that the top is going to be positive 0.3853. But I do want you to understand how the calculator can find both of those numbers for you. But keep in mind, when you do use invert norm, it's all about the area below, the probability below. So drawing this little picture here with 30% in the middle, 35 below, 35 above, might be very helpful for you. All right, now what do I do? Remember, I told you there's 3 steps. Number 1 is just understanding that the middle 30% has 35% above and below. The second thing is finding the z-scores that mark the ends of that interval, which I just found, negative 0.3853 and positive 0.3853. Now I have to take the z-score formula and back solve to find the actual time in minutes that those z-scores represent. So once again, my process, on this page, I want to walk through the whole process, right? So the question wanted me to find the middle 30%. I know that that means 70% is left out, 35% at the bottom, 35% at the top. I then use my calculator to get the z-score right here, negative 0.3853. I then use my calculator or my common sense to get the z-score right here, positive 0.3853. Now I have to solve for x, the actual amount of time that that z-score represents. I know the mean is 15. I know the standard deviation is 3.5. All you got to do is solve. So multiply the 3.5 over, then add the 15, and you can actually type that all into your calculator at once, and you get 13.65 minutes at the bottom. And then again, same thing over here. Multiply over the 3.5, add the 15, and solve, and you get 16.35 at the top, and that's in minutes. So the interval from 13.65 minutes to 16.35 minutes is the middle 30% of time it takes Josh to wash a car. So there's a 30% probability that it'll take Josh somewhere between 13.65 and 16.35 minutes to wash his car. Okay, that's a pretty good problem. So I'm going to stop this video right now. There's actually lots more to this topic, but we're going to put that in part 2. This is just part 1 of the video. So hopefully you understand how to use normal CDF and how to use invert norm to help you solve these questions. We're going to learn a lot more in the next part 2 of this topic, so please stay tuned.